Okay. Here, I'm going to switch it really quick. Okay, so good morning, everyone. Welcome, CS 201 students. My name is Trina Gregory. I teach for the ITP unit here at in Viterbi. I don't know if any of you have heard of us. We teach more of the practical classes, and we teach classes to non-CS and non-Viterbi students. So we actually teach programming classes, but we teach them to the non-CS majors. We also have lots of minors. If you're curious, the back of my t-shirt has a lot of our minors and stuff like that, so which you can always do as a CS major as well. I am in charge of there's a new minor that starts on Monday, which is mobile app development, so that's where I come from. I was a software engineer for many years and then started teaching about like six or so years ago. Okay, so I'm going to do that. Oops, I'm going to swap. There we go. And so this workshop is just to help you guys kind of get up to date on Java. Okay, because you've had your C++, and we're going to get you up to date on Java. I put this cartoon in because I thought it was funny. Oh, to start out with, right, this is the symbol. You see the symbol of... you see this is the Java symbol. If you've ever seen it before, sometimes they'll have like steam coming out from it. Here, I'll show that. You can see that. Oh, you can't really see it from there. Anyway, I'm looking at this. And then that little guy there, does anyone know? He's the mascot for Java. Does anyone know his name? His name's Duke, just so you know. His name's Duke. I really think it should have been Joe, like Cup of Joe. Java, coffee, anyway. His name's Duke. Here's a little cartoon for you. I thought it was kind of funny, you know, only one thing gets me going in the morning, and that's a hot steaming cup of Java. You know, anyway, very cute. So there you go. There's your little, there's a couple of little fun slides in here for that. So it's just a one-day workshop. We're just familiarizing you with the Java programming language because basically, because you already have C++ under your belt, they're expecting you to just pick up and know how to program in Java. So we're just kind of bridging you from C++ to Java, telling you kind of what's similar and different so you can program in Java. The book, so we have the book here that you're going to be using for 201. So we're covering in this workshop, you see chapters 1 through 6, 8 through 11, 14, and 22. 7 is just multi-dimensional arrays, so that's why we're not covering it, because if you know arrays, you can do multi-dimensional arrays. So there you go. Here's our quote schedule, though I think I'm already a little behind. So we have our morning section. It's just lecture and lab. Then at 1, we'll break for pizza, and then we'll, once again, in the afternoon, have more lecture and then lab as well. And the lab is really supposed to help you with, practicing some of these skills that you're expected to know. The 3 teachers that are doing this, the instructors are Nathan, me, and Rob. We all work for ITP. So if you want to check us out and find out about us, you can check us out on our website. Here's some great Java resources. The top one is the official Java API. Built into Java are a whole bunch of packages, like libraries that you can use, classes you can use to use, right? It's like those libraries, someone's already created a linked list. We'll use a class that already does that, right? Someone's already created an iterator, use that, an enumerator. So that's the whole, there's tons of stuff for you guys, and we will be using that as well. If you want my reference as well, you'll see I've already put some stuff up for you guys as well, like a job, and I put an Eclipse, like a short page Eclipse hotline, and then there's the downloading. So what is programming? Just kidding. You already know what programming is. You don't need to sit through the whole cycle of programming. Okay, so Java background. Yes, you can see that we had created some movie posters to kind of make it fun. So Java is an object-oriented programming language. And yes, C++ is an object-oriented programming language, but you can write non-object-oriented programming code in C++, right? It will also compile C. Do you mind shutting the door? You can also take your C code and compile it with the C++ compiler, right? And it's really not object-oriented. So there's more things that are enforced in Java to be object-oriented. It is free. It's a high-level language. And there's different flavors. If you saw, like, you can download the JDK. You can download the ME version, Mobile Edition, EE, Enterprise Edition, and SE Standard Edition. So we had you downloading the Standard Edition for Java. Okay. Here's some vocabulary you need to know for Java. JVM is Java Virtual Machine, JRE is Java Runtime Environment, and JDK is a Java Developer Kit. So if you're a developer, you want the JDK. If you just want to run something, or like in a web browser, just has the Java Virtual Machine, JVM. Okay? So if someone says, oh, the JVM, the JRE, JDK, you'll know what that is. Java applications. So there's two types. When you write Java code, you can compile it and run it as either a Java applet or a Java application. So Java application is what you're normally like a program, right? You have like an executable and you run it. That's what a Java application is. Standalone program requires the JVM. To run it requires the JVM. So even if you give someone your code, it needs to have the Java virtual machine on that machine to run. It's built into a lot of operating systems. The JVM is built into a lot of the operating systems and web browsers as well. So, example, Java applications, Eclipse is actually written in Java. How funny is that? Right, it's really cool. Eclipse is an IDE, an integrated development environment. Software to help you write software. That's written in Java, which you're writing Java. Isn't that kind of like Minecraft? Any Minecraft people out there? I know. So it might be. I have two boys. You'll hear about my kids today. 7 and 10, total geeks. Love Minecraft. My older son, actually did some game modding to mod Minecraft, right? Because Minecraft's written in Java. How cool is that? So, and Android, of course, right? So Android, you think about the Android operating system like mobile phones. Android is, when we do Android development, it's really like an extension of Java. So if you know Java, that's the key you need to know to help get you to be Android programmers. Okay? So, and then there's Java applets. Those are the ones that run in web browsers. And you probably have seen them. One example, a real popular example, is uploading pictures. Like you go to Shutterfly and you upload your pictures, and there's like a little applet that lets you upload your pictures. That's usually a Java applet. Sometimes you'll see it loading and you'll see the coffee cup in Steam. It doesn't say Java, it just shows you the coffee cup. So there you go. Object-oriented, powerful, more complex items like pointers have been excluded. Look at no pointers. Actually, there really are some pointers behind the scenes, and I will talk about some of that, but it's not as direct, right? So they've taken a lot of that away for you, okay? The memory management, they've taken, as long as you do things the right way, it's all taken care of for you. It's actually a lot easier. No malloc, no free, no release, all those kinds of things. You'll see we do it. And Java is platform independent, so you write once, run anywhere. So the idea is you write your code once, compile it, and then it'll run on a Mac, it'll run on a PC because of this Java virtual machine. Motivation, develop for a platform, blah, 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 blah. Okay, I'll skip some of these. You don't really. So most standard development, what you're used to, like C++, right? You'd have a C++ file, you'd have your code, right, your source code in a .cpp file. You would compile it, and then you would run it. But it would only run on whatever machine you're compiled it for. Well, Java's a little bit different. And then there's interpreted code languages like Python, where it runs in an interpreter. So you actually code real time and it runs it. So compiled code, interpreted code, what is Java? Java actually combines both. It's compiled and interpreted. Okay? It compiles your code into what we call bytecode, and then the bytecode is interpreted by the JVM that's running on the different machines. So there's a JVM for Mac, there's a JVM for PC, but we take our one bytecode and it'll run on both of them. Okay, so just so you know. kind of this is how it works. We write our code, right? And all our files end in .java. That's our source code, ends in .java. We compile it. Usually that's handled by our IDE, which in this case is Eclipse. The compiler is built in Eclipse. So Eclipse is actually, software, but it tied down to your JDK. So it needed to know where your JDK was, which contains your compiler, and then it compiles it for you. Okay? So then it creates bytecode, which ends in .class. Kind of confusing because we use classes all the time, but anyway, ends in .class. It's the bytecode that you can't open in any kind of text editor, and then we execute it, we run it, and the Java virtual machine does that for you. So, okay, so I'm a big one at learning. It's great to learn multiple programming languages, and you'll see the similarities, you'll see some of the differences, but the fundamentals are the same. It might just be syntax. And we're kind of bridging you, just showing you what the different syntax is. Okay? So overall, syntax and output. Let's do hello world. Instead of just looking at these slides, I think it's far more interesting to actually just run Eclipse. So if you've got Eclipse running, why don't you open it up? Okay? So here's Eclipse. If you got the workstation, the first window, there's an icon you click on the right. Did anyone get that? Or kind of the welcome screen thing. You should see something like this, though your package explorer will be empty, probably, because you haven't created a project yet. So let's create a project. Different ways you can do this. There's always the file, new, Java project. I get really used to using the toolbar up here, and this is the new right here. So if you pull this down, you can say new Java project. So go ahead, if you guys want to do it with me, if you haven't done it yet. New Java project. Project name, your project name can be anything. It is going to create a folder of that name under your workspace directory. So under your workspace folder on your machine. So you can call it whatever one. It can have spaces. You may, when you turn in assignments, maybe you're going to have to put like, lab 1 and then your USCID. Or your username, I don't know what he's going to make you do, or your last name, I don't know. But you can put whatever you want. So I'm just going to call this one Hello World. You can put spaces in the project name. Okay. We're going to use the standard stuff here. We're going to, because of what Professor Wachinski does, he likes the separate folders for source and class files. So we're going to do that. I'm just going to try to keep doing that because that's what he'll want in your class. Okay? So what that does, and then we hit finished, and woohoo! You can open this up and see what it's going to do is create a folder called SRC, which is source. So all your .java files are going to go in there automatically, and then .bin. There's going to be a bin directory, and all your .class files are going to be in there. Okay? So now we're going to create a new file. You can go here and do like new, and we're actually new at Java class. So Java is object-oriented, so everything has to be in a class. Everything has to be in a class. Everything has to be in a class. Just know that, okay? So you can click that there, or I like to use the toolbar up here and just click here. So click here. It's great. It's got my source folder right. We're just going to use the default package. He may, in the class, give you something that he wants certain things in certain packages. So we're just going to leave it as the default for now. Now for the name, this is going to be your class name. It cannot have a space. Okay, no spaces. And you can create a class file without a capital letter, but the Java convention, and we're really big on making sure you do the Java convention, is you start it with a capital letter. Okay, so hello world. Okay, so hello world. Now, we're also going to, I'll talk about superclass later, but we're also going to select this as well. Can you not see? It's hard. I know. I want to put this down. Okay. What?
Is it a copy?
Oh, yes, okay. I can push that down. I don't know if I can. Okay. Anyway. Darn monitor. Like that. Okay, so there we go. Is that better or worse? Trying to get it down. Okay, so so I'm going to do that. I'm going to select this one that says public static void main. Every Java application needs a starting point, and that's your main method, just like you're used to, right? You're used to that from C++, right? Main being the starting point. So the same thing here. Hit finished, it's going to create. And it's going to create what we need so far. We're going to go over more detail about what all these things mean. But just to start out with, we're going to do this, and we're going to do a simple hello world, right? Because hello world's supposed to be your first programming. In any language, your first program in any language should be hello world, right? Right? Yes? No? Okay. It's from the K&R book, Carnegie and Ritchie, the C standard little book. All CS people should know. If you ever say K&R, it's the Carnegie and Ritchie book. Okay, so we're going to do a very simple system.out.println hello world. Okay. So in Java, you'll see we need to, everything's in a class, so that's what this public class hello world. In Java, that name, that class name, matches your file name, and it has to match your file name. Has to match your file name. Big thing there, okay? In C++, you don't have to do that, right? You have to match the file name, right? So hello world, and then we're going to have our main method. And there's some identifiers that come before it, some modifiers that come before it, but in Java, the main method is going to be public static void main, string args, and then we can put our stuff in here. So this is where we start putting our code that we want to do. We'll talk about all the different modifiers down the road, but I'll just point out here that, so this is the name of the method, main. This is the return type. So right before it is the return type void, and then of course here are your args in here. So system.out.println, guess what it does? It prints a string, right? So that's what this is here. In Java, notice that strings are in double quotes, so you have to put double quotes. A character, a char, is single quotes, and it's double quotes. So we're going to do that, and now we can run it. This arrow, you can go up and hit run. I tend to use, like I said, the toolbar up here, and this is the run. It's going to ask you if you haven't saved it, whether you want to save it. You can always save resources before launching, and then you won't see that come up every time. And there you go. Down in our console window, it says hello world. Yay. Very simple. Okay. So this is your Eclipse IDE. Okay. Over here, you'll have your Package Explorer. Don't worry if you ever things ever go away, like, oh, I close this. You can always open it back up again. Don't worry. It's all here and under Windows, navigation, open perspective. There's all kinds of different views here. So here's your Package Explorer if it ever goes away. If there's probably stuff on this side as well. You can close those down. We're not going to use them. There's like a task list and some other stuff. Go ahead and close them down, only because I like to have more space. Okay? And then down here, you can close these as well. But one of them that you'll see is like the console window. So this is letting us get our output. Okay? And so there you go. That's very, very basic. Like I said, you're gonna do things like even here you can right click, and from like here I'm at my hello world. You can right click. You can do different things. I know. Professor Wachinski is going to have you import stuff. I think that's how he's going to have you do it now. Import. We can do all kinds of stuff as well. Now, say you don't like the name Hello World. Say you want to change it. Do not just go in here and change the name, because it's all tied to the file name and then the package, and it knows which files to compile, all that kind of stuff, right? So never just change the name here. I'm teaching you the right way to do it, which is just select it, right-click, and hit Refactor, Rename. So say I wanted to change the name to, any suggestions? Name? Okay, name. There we go. It's going to come up with this window. You hit, and notice how it changed it. My Package Explorer, here's name, Here's name, right? So it does it all for you. So that's the right way because it cleans up anything that it has to. Okay? And I know there's times you're like, oh, I really want to change the name or I misspelled it or something like that. So, like I said, just use that rename. That was one thing that Professor Wachinski really wanted me to show you. It's like, make sure you show them refactor. Okay. I also have for you just a really simple help page, which is like opening up Eclipse. Everything needs to be in your workspace folder, so make sure that you, like I said, I would create a folder called CS201 and then a workspace folder underneath that and just put that as your workspace folder for your class. Okay? Here's how to create a new project, create a new class, open and modify a project, save, run your application. Some other really cool things in Eclipse is indentation, right? Indentation, quote unquote, doesn't matter in the fact that a compiler, those spaces don't matter, right? That doesn't matter, right? I just took out that space. Doesn't matter. You can write really messy code. The compiler will still compile it, right? But it's harder for you, the coder, and other people to read it. So indentation is really important, but there's shortcuts to fix your indentation. You can actually go through here, edit, select all. But an easy way, I'll tell you the short keys to do it. If you're on Mac, just do Command-A to select all, Command-I, correct indentation. If you're on Windows, it's Control-A, Control-I. I tell you, that's going to save you tons of time. Yes?
You said that everyone's big on the Java conventions for this. Is the Java convention to have the bracket at the end of the line?
You know, that's personal. I have not seen... Okay, yes, that's one of those things. That's not a Java convention that's... You're welcome to do that. I know a lot of people that would rather see them link up that way. And you can actually tell Eclipse, you can, in your preferences, you can tell Eclipse to do that for you. So under Eclipse preferences, there's like all these menus, but you can actually make it do that. That's not a convention, that's not like a Java convention. So, but I will tell you things about like how to name things, right? That we care more about. Okay? So I'm going to leave that for now. Oh, and I'm going to show you some other tricks as well. Java's great at doing some autocomplete or content assist, as they call it. It'll help you write code. Okay, so we'll get to that when we do our when we go to the new class. Okay, yeah, content assist is great. Okay, so I'm going to go back to the hello world. This is what you're used to. Come on, no signal. There we go. There we go. There we go. Come on, you can do it. Okay, yay. Okay, there's what you're used to in C++, right? That's what you're used to. This is it in Java. Okay, public class hello world. This gives us, the public tells us our class access. For now, all our classes are going to be public, which means other developer, if we gave it to them, they could use that class. Class, we're saying we're creating a class, like object-oriented classes, everything's under a class. Hello world, that's the name of the class. Like it says, we like to, class names start with capitals. Okay, class names start with capitals, and purposely did this as well. Notice if we wanted to be like another word, we use camel case. Has people heard about camel case? That's what this case is called, where it's no spaces, but for every new word is a capital. It's called camel case. Like a camel, like the humps on a back. That's what it's from, humps. Cute, huh? So that's what we highly suggest camel case as well. Versus underscores, okay? Everything in Java is in a class, so each program has to have at least one class, and then each class, and then just one class in your project needs to have that public static void main method, because that's your starting point. Okay? Okay, so access, this is kind of return. Okay, here's the public static void main. So access level for this main method, it's the main method, it needs to be public. Static, we're going to get to that more in a little bit. Void is the return type, that's the name of the thing, and then there's our method arguments. Okay? So public static void main is equivalent to int main. And that's your starting point. Static, this creates a class method. And we'll get into this more, but do you remember in creating methods that there's two types of methods? Maybe? Remember? Instance methods and class methods. Yes? No? Object-oriented programming. Think object-oriented programming, right? Instance methods and class methods. So a instance method means for every instance of the class, right? You create different instances of your class. You get basically a unique method, right, for each of them. You run it. Whereas a class method, it's the same for all instances of the class. We'll talk more about it. We'll continue going over this point. Breakdown, hello world. Okay, so to print out something to the console, we're using system.out.println. Okay, the syntax between C++ and Java is very similar. Statements end in a semicolon, just like C++, like you're used to. Curly braces to do, blocks are the curly braces. Parentheses, we use those, right, in expressions and arguments. White space in code is ignored, but is ignored by the compiler, but we as instructors, graders, even you as good coders want to make sure your coding, the indentation looks good. And proper coding style is important as well. So comments, the same. You're used to the double slash, forward slash. That means that's a comment till the end of the line. We're going to use block comments as well, right? You're used to those, block comments. And Java's a little bit different. We also have this where you do the slash star and you put another star, okay? And what that does is that the compiler will auto-generate some Java docs for us if we want them to. Automatically create documentation for your code and like a web page. Yeah, it's great. What? Yeah, it's great. So if I go back I'm going to go back to Eclipse. Good standard, right, is you make sure the very top of each file has information, right? Put comments. So I'm going to go back in and do the double star and notice what it did for me. It automatically does, and it does that automatically because it's just kind of a style thing in Java. So if you do a slash star star and then hit return, things like, it says at author, and that will create, see, some of these things at author, just leave it there, and it will do it, it helps do the Java docs for you. So I'm a big one at making sure you always put your name, right? Maybe your email address, for code, maybe your student ID, whatever, that kind of stuff. First Java program, yay, right? Something, I don't know. Maybe, always good to put like a date or what's this referring to, so I'll put Java workshop, what is this, 2013 or something, I don't know, something like that. Fall 2013, I guess, 'cause something like that, okay? So those are block quotes. We like to put our block comments. We like to put those comments right at the top of the file. Good code, good convention is at the top. In front of certain main methods, right? This one's kind of an easy one, being a main method, but I could still do something like, main method, starting point, so for the application. Okay? So there you go. We'll save that off. I was trying to get that to come down. There we go. There we go. Okay, I'm going to go back to PowerPoint. Every time I do this, it kind of... Okay, so there you go. There's our comments. Yeah, there's our comments. So output. You're used to probably using cout, right? Cout and cin probably for getting output. We're going to use system.out to put stuff to the console window. Print just does the string, so, and everything has to be in a string, so it's just a string, so double quotes. And then print just does that. Print line does the string and then starts you on the new line. Okay, so easy. We can also concatenate strings with a plus sign. So if you wanted to add like foo bar together, right? Or we can also do escape characters. So \T is a tab. \N is a new line. So say you had a whole string and you wanted to put a return to make it look nicer. \N is a new line. There's other ones. Now notice that the backslash is used to say it's an escape character. So if you actually want to print a backslash, what do you think you have to do? 2 backslashes. There you go. See? Okay. So yes, aren't they cute? We have a little bit of fun in making slides. So now variables. Okay, so variables must be declared, right, before being used. To declare a variable, you have to give it its type and then a variable name. Okay, Java's type specific. You have to give it a type. There's some programming languages like Python, which you don't give it a type, but Java, you have to give it a type. Declaring multiple variables, right? You can do it on the same line with a comma, as long as, it's like these have to be, this is a double, X and Y are both doubles. You can do it that way. You can also initialize it on the same line as well. Okay. Simple data types. So these are known in Java as the primitive data types. Notice that they're all lowercase. Okay, these are the primitive data types in Java. We have byte, short, int, long, float, double, char, boolean. Okay. Is there anything, I didn't say this yesterday, but anything you don't notice? We'll get there. Notice anything about the numbers? They all they're all signed, yeah. Yeah, they're all signed. Okay, so there's no right, unsigned int. There's none of that. They're all signed. Okay. Okay. So these are simple data types. They're not objects. They're just simple data types. So you can create an int, and that's the range for it, right? So if a number has to be a number between there, long, float, double. Okay, so okay. Makes sense? And then we have char, which is, a single character with the single quotes, and a Boolean, true or false. Used to using Booleans. In C, right, Booleans, they really equate to an int, right? Here it's its own type. It's not an int. It's not a 0 or a 1. You can't say it's a 0 or a 1. The values are reserved word true, reserved word false. Okay, so it's a reserved word. You type in true, yeah. Okay, so when you create your variable names, make sure, like other programming languages, right? It's alphanumeric. You can use letters, uppercase, lowercase, digits, 0 through 9, the underscore. In Java, you can also use the $sign, but that's really used for legacy systems, so don't use it, basically. And you, of course, can't use reserved words, right? Like int, static, right? These have other meanings, so you can't use them. You can go to the link if you want more information. But the important thing to remember is that that the first character cannot be a digit. Okay? So it can be an underscore, it can be lowercase or uppercase, but it can't be a digit. It can be even a $sign, but don't go there. Okay? So style rules. So you see that the primitive types start with all lowercase. Anything that starts with an uppercase is going to be a class type. So there is a class for you called string. Yay! And we're going to get to that and all the fun things you can do with string. So that's going to be basically a class. You're creating an instance of string. Okay. All variables. This is a very important convention. Is our variable names, we start them with lower cases. We don't start them with uppercases. Okay? In Java, that's just a thing. Because class names always start with an uppercase, so variable names always start with the lowercase. Okay? And then use camel case, right? So, I want day of month. Put day of month. Right? Okay. Char is it's represented with single quotes. Okay, so you have to use single quotes. You can't use double quotes. Double quotes is used for a string. So you're basically going to get a type mismatch. So you cannot use, if it's double quotes, it thinks it's a string. So you're not even going to compile. Okay? Boolean, like I said, has the values of true or false. It is not an int. Like in C++, you could convert it to an int because you could get a value of 0 or 1. Can't do that here. It's its own type, and its values are true or false, period. Okay? Operators, same as C++. So remember the shorthand plus to increment by 1. You can do that. Minus, all that's the same. Even like you can do the plus equals. So if I create a variable, here, let's go back here. So let's go back to Eclipse. So let's create some variables here. I always like to do my local variables first here, so we're going to do that. So here's my local variables. Say I create a number, right? Num equals, give me a number. Anyone?
5.
5, great, awesome. Okay, num, okay? Now I want to, maybe I am going to print out my num, okay? Maybe I'll do it after here. So say I say num equals, and then I can do a plus to add in more stuff to the string, concatenate to the string, and then I'm going to do, I can put a variable name and it will print out the value of the variable. Okay, so I can do num equals that. Okay, great. We run it, save it, run it, and we get, hello world, num equals 5. Yay. Say we do something, we're going to increment it. We can do num plus equals. Remember the plus equals? So the plus adds it to itself. Plus equals adds whatever you want. So say we said 10. Now I print out num again and save it, and num equals 5, num equals 15. Yay! Very simple, right? So all those things you're used to from before in programming languages is the same. Okay? Okay, so those are the same. We have, so all those operators. Order of operations, very important, right? Order of operations, how is it going to evaluate? How's it going to do all the calculations if you have a, multiplication, addition, subtraction? Remember, PEMDAS, what does it stand for? What's the P? Parentheses. What's the E? Exponent. M. Multiplication. Addition, subtraction. Really, there needs to be a parentheses here around the MD because MD, it doesn't do all the multiplication first and then the division. It does multiplication, division. Does that make sense? Right?
Didn't already know PEMDAS. How would that make sense?
True. But you know what I mean? You really, the MD are together and the AS are together. So, okay? And then we'll do Boolean operations after that. Okay, so we'll do the unary, the PEMDAS, and that. Okay? So there you go. Typecasting, it will automatically convert to a larger type. So basically it's based on size, like how many bytes is it using to hold an int is less than the number of bytes it's using to hold a float, right? So it's easy to take an int and put it into a float. But it's hard to do it the other way around, right? Because you're taking away space. So it'll automatically convert to a larger type. So if a equals 8, and you could say float x equals, it says, oh, okay, you're just 8.0, no big deal. It's harder to do on the other way around, okay? So in C++, it would just simply truncate it, right? Right, if you did this, it would just take away anything after the dot. Remember that? Right? It just takes away all that information. Even if it's a 0.8, right? It doesn't round, it just truncates, it just takes it away. Well, the same thing is going to happen here, but we have to typecast it. If we want to go to a lower one, we have to typecast it. So we have to say, if this is a float, right? This is a float. So we have to say, I know it's a float, I know I'm truncating, right? It's basically you're saying, I know, okay? Make sense? Easy? Okay, so we're going to do a little bit more into strings. So string is a class, okay? It's not a primitive, it's a class. It's a capital S. Notice the big, very, while we're on that. So remember, always, people mistype things, I know, but like most programming languages, Java is case sensitive. Java is case sensitive, right? So a capital S string is different than a lowercase string, right? So like most programming languages, they're case sensitive. So important to remember. So it's a capital S because it really is a class, right? Officially, we should do things like creating a new instance of it. I'm going to get to that later, but because we use strings so much in Java, there's a really easy way we can just say string greeting, greeting equals hiya, or string greeting equals hiya, right? You can just create a variable of type string and then just assign it. Easy. Okay. We put this slide in here as well because you're going to need this for your first lab. Strings are, the way we do strings is they are classes. We create an instance of a class. So you can't just check if something's equal with the equal signs, right? You're used to the the double equals. You can't do that. You have to, we're going to call methods. So I'm going to get more to this later, but we put that as kind of a reference for you. Okay, so input. This is different from C++. So wake up in case you were sleeping. Funny, right? It's funny. Okay, so input, reading input, we're actually going to use a class called the scanner class to read input. Okay, and it lets us do actually more than just read input from like your keyboard. It lets you read input from a file, which is great. And we'll be doing that in both cases. So reading input, we're going to use we're going to use the scanner. Now notice up at the very top I have to do this import java.util.scanner. It's outside of the class. Generally you create a class and all your code's in there, except for these kinds of imports. That's the only thing that's going to be outside of the class. That and comments, right? So that's the only thing that's going to be outside your class. We're basically saying we want this package. In this java.util package, there's the scanner class. You can think of it as a library. Okay? And we're using an import, not include. I know sometimes you come from different programming languages and you're like, include. No. It's import. So import is the Java reserved word, that we use. So in our class, this is how we're going to get input. So I think I'll just jump back to Eclipse, and that way you can do it as well. I think it's more fun than just reading slides. Let's input some information. So we said hello world. Well, why don't we go in and we are going to ask someone like their name and print their name. Very easy. So like I said, we're going to need to do this import. So I'm going to come up to the top outside the class, import, but below my comments. I like to keep my comments the first thing. Import java.util. Okay, notice I'm already seeing like people looking at Eclipse, and yes, it has that red because we haven't gotten to the end of the statement yet. So don't freak out sometimes when Eclipse, you haven't even finished typing and it's like, oh, there's an error. There's not an error yet. And the yellow is just a warning. When you see a yellow, it's a warning. And you can hover over it or even click on this right here. It's basically telling me it's never used. Well, yeah, I haven't gotten there yet. Give me a moment. Okay, so under my local variables, I'm going to create a variable for my scanner class. So scanner, and then we give it a variable name. It can be any variable name you want, okay? I'm going to put input because I'm getting input. Sometimes I put KB for keyboard, whatever you want. New, this reserved word new, scanner, system.in. So I know that seems a little long, but it's okay. So I'm creating a variable of type scanner called input. I'm basically creating an instance of this. So to create an instance of something in Java, we use the reserved word new. Okay? And that basically handles all our memory for us, our memory allocation for us. All our memory allocation, all handled by the new. Okay? It's basically, we're going to get to it. It's basically creating a constructor, and then we're going to pass in this parameter of system.in. And system.in Notice we did system.out before, which printed to the console. System.in means we're going to be typing on the computer in the console window, and it's going to take our input. Okay? So we do system.in, great. Now I'm going to create another variable. Let's create a string variable called name. Okay? So I say hello world, and now I want to tell the user to enter their name. Please enter your name. Or what is your name, or whatever you want to do. Make sure there's that semicolon at the end. Now we've asked the user to do it, but we haven't actually gotten the data. So what we do now is on the scanner class, there's a whole bunch of methods that we can get input. And so if we do something, we basically use, we call different methods on input. So, and you see, if I just do input dot, it's showing me all the different stuff I can do. And the one I want to do is next line. I can even just double click on it, next line. So that's a start. That's going to get the input, but it actually returns what the user inputted. So I want to put that into my name variable. Right? That makes sense for everyone? So name equals input.nextLine. So like I said, input is this variable, scanner, which lets me get input from the keyboard, and then name is a variable of type string, and that's what's going to be returned to me. Next line returns a string. See, it tells me. Okay. So now we could do something like, do you mind if I'm just going to delete this number code. You don't have to, I'm just going to do that. Now I could say something like system.out.println welcome plus name. And you'll notice there's one other thing we need to do at the very end of the program. And you see this little error here, this little warning. It's not an error, it's just a warning, the yellow. It said that input was never closed. So what we do at the very end as well is we just put input.close. And that closes it. Yes?
Do you do that once you finish using it for everything, or each time you're finished?
When you're done at the very end. I generally will, yeah, just at the very, very, very end of my whatever I'm doing. Yeah. If I've opened it, you basically open it, you use it as much as you want, and then close it at the very end.
That's like deleting
Yeah. It's basically, it's kind of like releasing it. Like saying, oh, okay, yeah, you can use the thing. You can use the console window. We're not using that anymore, kind of thing. So, yeah, so just input.close and you're good. Save it. We're going to run it. So who's going to give me their name?
You asked everyone's name.
I don't remember everyone's name. No, I remember Josh's because you called him out. Isn't that funny? Okay, Justine, how do you spell it?
Justin.
Oh, okay, Justine. Okay, wonderful. Welcome, Justine. Okay, so there you go. So very simple. We are going to add more stuff. We can get numbers as well. So say we wanted to get a number, like we want someone to say, what is your favorite number? You're geeky people. You have to have a favorite number, right? So I'm going to say num equals, and I can actually put, instead of next line, which that's going to give me a string, I can actually say next int, and that will return an integer for me. Okay? There we go. Okay. There we go. So for num, you can, like I said, there's lots of different methods here. So next int, there's next byte, next short, next, which just does a word. Yes?
Since it's next int, can you type in a bunch of stuff and then type in a number at some point, and it won't take the stuff until you type in the number?
Yes, yes. You can play around with it, what it will do, but so, Justine, you gave me your name before, so Justine, what's your favorite number?
14.
14. So if I do other stuff, oh no, oh, yeah, no, it didn't like that. Yeah, well, we're going to talk about exceptions, but it's supposed to find, like, I think if it's you do spaces, it allow it, but not. Run it and see. We're going to talk about how to capture exceptions like that. But well, easy, I'll not error check. Your favorite number is 14, yay. Yeah, it's supposed to basically find a number in it, but I think if it's like the first number, it's fine. If you put stuff afterwards, play around with it. See what happens. So if I did like 14, no, it still throws an exception. Input mismatch. We're going to catch those. Don't worry, we're going to catch those. Okay, so very basic getting input from the user. Okay, there we go. So we're using the scanner. Just get used to using the scanner if you're going to do any console window input. Just know you have to do scanner. Okay? So system.in is the standard input device, which is the keyboard. We're using it. It's in the util package. Yeah. Okay, next, here's some ones that we use a lot. There are some things where the next and next line and next it can actually get you into trouble. And I'll do an example of it. Because there's an example on the next slide, but I think it's easier just to see it live. So what if I said, now that I have your favorite number, I'm going to ask, I'll just put it up here actually. And make sure when you do input, right, you're just going to get a blinking cursor. This input here, this num equals input.nextInt, whatever, it just does the blinking cursor. We need to always ask the user or tell the user what we're expecting from them. Okay? What is your favorite color? Yay, what's your favorite color? Okay? So I'm going to say color equals input dot next line. Right? Because maybe their color has multiple words to it, like chocolate brown, or cardinal red. Oh, there's very USC, right? Cardinal red. I'm wearing cardinal red. Okay, so I did LN, sorry. I just was, sometimes I mix up the print line and the next line, and one is line, one's LN. I wish they would have been consistent. Okay, so now when I run this, oh, and then let me I'll print out your favorite color is. Okay, so now I'm going to run this, and we're actually going to have a problem. And let's see if you can figure out what the problem is. So here's the code right up here. I'm going to move my console window up here. So, okay, Justine's already done it. Someone else, give me your name. Zach. Okay, Zach. Do you do it with a K or an H? Okay, I know people that either way. What's your favorite number? 22. Do you see what happened? Yeah. It jumped ahead. Do you want to kind of guess why?
You hit enter.
I hit enter, right? So after the number, I hit enter. So this next line took that enter. Okay? So sometimes we'll have to do something like this, where grab the return or the enter, right? So I'm just saying input.next line just to grab that. Yes?
Is there a way to tell it to take what you just typed without hitting enter?
It actually does. I think it already takes it. So if we had...
How can you tell it to move on without hitting enter? You type in 22 and then it doesn't do anything until you hit enter. Is there a way to make it realize that you're done without hitting enter?
So if we did it this way and ran... oh, I'm sorry. I didn't want to do that. I'm sorry. I want to run it again. Now it, oh, see? All I did was put a space, and I typed red, and then I hit enter. Of course, then I get my system, .out.println, what is your favorite color? Do you see what I'm saying? So there's times when we'll ask for a whole bunch of input on one, but you just want to tell the user that, right? It's all kind of the user, what you expect your user. When I ask one question, I kind of expect the user to do, enter that and hit return, right? Don't you kind of expect that? I just jumped ahead, guessed your favorite color was red, which it probably isn't, but there you go. So I'm going to take this back out so I can grab the return, so then I can really ask Zach, what's your favorite color? Purple. Awesome. See? There you go. Okay? So that's just one of those like gotchas that could happen sometimes. And people are like, I didn't get the data. What happened? Blah, blah, blah. It's like, oh, well, if you do some of these like next int, next byte, next short, it's just looking for a number, the next number, and then when you do a next line, the next line is getting the return. Even next is, you can use just next, and that just as a word, just a word. So you could do like next, to get a whole bunch of words if you wanted to.
Would it translate it as a string? So if you typed in a number, would it take it as a string?
Yes. Yes, next is, yes. Next means it's a string. Yes, absolutely. Okay, so that's what some of this is about, is doing that kind of stuff. Okay, so flow control statements. You can laugh at the picture. Okay, so great news is these flow control structures, like if, else, right? The whole branching, I want to... Normal programs, it's sequential, and you want to change the flow of it. You want to loop or do, branch off to stuff. Then that's luckily it's same as C++. We have the if. You got it working?
Yeah.
He got it working. That was a yay, happy.
Yeah.
So the if is the same. Remember to put your parentheses. Doesn't work without the parentheses. You can do the else, if, else. You don't have to have an else. You have to have an if. You don't have an else. So all those same rules apply. There's the same rule as if you don't put curly braces for the block, it'll only do one line. Right? You know that? I suggest that you always just put curly braces. That's my suggestion. When you're starting out programming, just always put curly braces. Even yesterday, I had a student who said it's not working, and he just had indented, and I said, you have no curly braces. He's like, oh yeah, that's right. So you're just starting out programming. Just put curly braces. Don't do the whole single line thing. Just don't. Okay. Okay, so the if else, so in the if, right, there's some kind of Boolean expression. It's something that equates to true or false. So it's the same as C++. We have those double equals is a compare, right? A single equals is an assignment. A double equals is a compare. So you've got the double equals, the not equals, the greater than or equal, less than or equal, all the same. Okay? So you have those. The logical ones as well, right? You want to group true and falses together, right? So is this true? You know, and you want to and it or it, the same thing. We've got the ands, ors, or the nots. Yes?
Would it register as dog equaling dog is true?
No. No. Not at all. So these are examples. They're not all true, but they're examples because, you know, ifs, they equate to true or false. Okay? And like I said, it is a Boolean variable, and it equates to true or false, not 0 or 1. So you have been used to doing something like this in C++, you cannot do. Okay? If you want to do this, you could say if a double equals 1. Or you can also do you know how sometimes you just want to loop until there's some kind of condition? You can put while true. You can just put the word true. See, it's even friendlier, right? So while true, or you can do that. Okay. Strings. When we compare strings, right? We compare strings. It really is comparing a lot of times the memory location of the strings. I say that there's some caveats with some intern strings, but so if I did S1 equals dog and then S2 equals new string, it's actually creating, when I say this new string here, up here, it's actually saying, okay, I'm going to put it, getting new memory for it. So it's putting it into a different memory location. So this will be false. What we can use, of course, is this equals or equals ignore case. Okay? And we're going to do more examples of that as well, but equals ignore case. So you put one string in here, and we can check if it's equals or equals ignore case. Okay. Switch, almost the same as C++. Okay. We can use ints, chars, or strings in the new version of Java, though I haven't played with that yet because it's new. So you're used to using, a lot of times we'll do it for like a menu, right? You switch whether someone enters in a 0, 1, 2, 3, 4, something like that, or a character, a char. So you'll switch on some variable, right? You switch on this variable, you have case, and then whatever that value is, like 0, 1, 2, 3, and then your statements. Remember the important break, right? Because if you don't put break, it just goes through to the next case. Do you remember that in switches? If you don't put the break. Right, you learned switches, right? Okay, and then the default as well. So there's the default at the end. So if it doesn't hit any of these cases, it will hit the default. It's kind of like the else, right? A switch is like a really big if else, if else, if else, if else, if else, right? That's really what it is. Okay. Repetition, loops, yay. Same as C++, you already know it. Great. The while, right? The while, parentheses, while something is true. It's true, not 0 or 1, true. Do those statements. So very easy example for you. And then the all-important do while as well. Remember the do while? What's the difference? Okay, besides the fact that which of them will always run through the block statements at least once? Do while. See, you're ready. Do while. So do, and the only thing that throws some people off for syntax-wise is, the while, parentheses, and then you have your block, your curly braces for your block statements. And each statement, of course, has a semicolon afterwards, right? Because it's a statement, it's a line you want to do, programming-wise. Very much like an if, right? If Boolean expression, curly braces. The do while, this is where there's just a little gotcha, is sometimes people forget to put the little semicolon at the end. Because it's having to run these statements first and then the while, to close it off, it has to do this semicolon here for the compiler. So that's the only little kind of gotcha sometimes that people like forget the little semicolon at the end. Or they put a semicolon up here. What happens if you put a semicolon up here? Do you know? What happens if I put a semicolon right here in the while? Not necessarily break it, but you know how a while, like an if, will do one statement or a block statement, right? So if you put a semicolon up there, that's your one statement. So it will most definitely, I mean, assuming that you're, changing your looping, changing whatever your Boolean expression is in your loop, right? You put it here, it's going to get into an infinite loop. Yeah, not so good. So no semicolon. Does that make sense? Yeah. So that can just little things that over the years I've seen like students do. For loops. For loops, the same kind of thing. Initialization, your testing condition, and then your update, right? We put semicolons in between. Make sure they're semicolons. I say that because you actually can do, in Java, you can init, right? You can init multiple variables right here with commas. So you can say init I equals 0, comma, int j equals 0. You can init more of them, and then the semicolon means, okay, I'm done with my init. Then you have your condition, where, of course, that has to equate to true or false. So you can have your ands, ors, all that kind of stuff in there, semicolon. And then your update here, you can actually update multiple variables as well. You can do I++, blah, and do multiple ones. So, but that can kind of get hairy, so anyway, just say. And they put commas in between them. So just noting, make sure you put semicolons. Okay. Break and continue, the same as C++, right? Break breaks you out of a loop. Continue continues to the next loop iteration. Breaks we use a lot in switches, and that's about it. I don't see a lot of continues, and I've programmed Java for years before I came here. So really avoid or use sparingly. I completely agree, right? Breaks we have to use for switches, continues. Sometimes it's not the best way to loop something, to break out of it and stuff. So there you go. Arrays. Ray. Kind of funny. Arrays. So arrays, a little bit, here's the same things. So down here in black, that's what's the same as C++. You have your access elements. You're accessing them with square brackets, right? You see square brackets, you think arrays, right? Its index starts with 0. You're used to that, right? We're computer scientists. Our number system starts with 0, not 1. The digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 0, you're used to that. It is a little different in the fact that an array variable is an object. It is an object. So we actually are going to use the reserved word new to kind of basically set that up for us. Okay? A variable is a reference to the entire object. You're used to the variable pointing to the first element of the object. When we point to the array, it's the whole array. To get that first object, you have to use the square bracket 0. Okay? But the great thing is there is a length, because it is this object, there's a length data member. Yay! You can do the variable name dot length and get the length of the array. How great is that, right? Versus having some other variable to keep how big your array is, right? Or that kind of stuff. So there's good things. So how we create arrays is we have our data type here. Then we put the square bracket, and the square bracket basically means, oh, we're going to create an array of this, right? variable name, whatever your variable name, follow the rules as before, equals new. So we have to use this new because it's an object. This new, we give it the data type again, and then we put the size. And this is how many elements we want. Okay? So, for example, here is I'm creating an array of doubles. The name of it is rates, and there's 6 elements. Easy. Okay? Just have to remember that we have to put this new. Now, you may be saying, why is this? You can, why is it so long? You can break it up. Sometimes we're going to say, hey, I need an array of names. I don't know how many I'm going to need. Maybe I'll ask my user, right? And my user says, I have 50 students. Okay, I'm going to create an array, right? Using what they inputted, I'm going to put that variable there, right? So you can break these up to different sections of your code. For example, in your first lab, right? Okay, so that's, you got to remember to do that. So because it is an object, we have to put this new. There is a shorthand, and that's if you have an array and you know what the elements are going to be. You can do this, and this could be for, like, this could be strings as well. I mean, it could be different types. But int, so I'm creating an array of ints, name scores, and then these are going to be my elements. You put these, this is a special case, square curly brackets, and it will say automatically, it does it automatically. It basically says, oh, you have 4 elements. I'm going to create 4 elements for you. It basically does the scores equals new int 4 and says scores of 0 equals 0, score of 1 equals 4, score of 2 equals 3, score of 2 equals 2, and score of 3 equals 1. So it sets that up for you. So it's a shorthand. But it's only good if you know exactly what your values are going to be. So that's why this isn't used very often, because you don't always know what your values are going to be. Okay. Arrays are reference types, so you can't copy it through an assignment. So if I do this, here, it's basically saying I'm pointing to that one. Okay? So it doesn't do a copy. It doesn't copy the data and give you your own copy of it. There's a way to do that, but not if you just do that. It's basically like pointing. It's just pointing to the same memory location. Okay? Does that make sense? Good? There is in for loops, there's a convenient way. Oh, this needs to be back in the thing. Oh, I guess because it's an array. For loops, there's a great way to loop through an array. You're probably used to looping through an array using like an iterator, like int I equals 0, right? And looping through. You can actually loop through an array by giving, it's really cool. It's what we call the for each array. It's nicknamed the for each array. And what it's going to do for you is you give it the element type, you give it the variable, right? This is your, for example, your names, say it's your names, variable, so index variable, names, and then you give it, and it gives it, this is your array variable. You give it the element type, so the type that it is, like a double, and then it creates a new variable name here. You give it a new variable name, and it will loop through the array for you. And you have an element. It's basically pointing this guy here, index variable, is pointing to that element of the array. Okay? So why don't we do an example so you can really see, because I think that would be better. So let's create an array of, what do you want to create? Strings, ints. What do you want to create an array of?
Characters.
Oh, the one I don't say. Of course you would do that. Fine. Char. So char equal, char, give it a variable name. You can do chars.
Yeah.
I mean, you really can. Equals, and now I could stop here and ask my user how many I want to do, but I'll just do equals new char, and how many. So say we want to just say like 4. Okay? So I have 4 characters. Okay? So I'm going to come in here and, well, we want to put values in there, right? So easiest way, right, is something like this. So am I just doing like ABC, or do you want to do something more IJK? What do you want? AEIOU? Hmm? Oh, you're right. It's a great idea. I started typing it before you said it. Okay, I know, not the most efficient way to fill an array. Usually we'd loop or ask users to input it or pull data from somewhere and parse it and put it in. But, okay, simple. We'll do it this way. So we have JAVA, right? There's our characters. So I can actually come here, watch this. If I do 4 each, and this is a great shortcut for Eclipse, and this is for Mac or Windows people, hold down the control key and hit the space bar. And then double click. And so it will do this for each array for me. So there's my element type, character. It creates a variable, very simple variable, C, you can change it, on characters. So now I could do something like system.out.println, and I could print just the variable C, right? Because that's my variable here. So that becomes the one it's iterating, right? So that's your new value each time. So Java. Nice, huh? It'll also let you do other for loops as well. So if I did this, I did for control space, I could also just do this one, iterate over array, and that's probably what you're most used to, is like I equals 0, characters.length, right? And then I would have to do a system.out.println, characters of I. So these 2 things, if I didn't mistype, okay, these 2 things, there we go. These two loops are doing the same one. This is our standard for loop that you're probably used to seeing. This is what we call a for each loop. Or you can spread the word out as well if you want for each, but that's how you do the shortcut. Okay? Cool, huh? So Eclipse will help do that for you. Does that make sense? So here's your standard way of accessing the array. I've got an array of characters. Characters is the name of the array. I can use my data member .length, characters of I, which is my index that's going to loop through my, for my for loop. These 2 things do the exact same thing. But you'll notice the top one, it grabs that element for you. So you don't have to index it. It's creating that element it's grabbing that element for you. Okay? Cool. Right? Maybe I'll put this down at the end. This is quite the crazy hello world. We're just throwing all kinds of stuff in there. Okay, so we have the for each. That's the for, yeah, so there's the for each example. There's a for each example for you. As well. Array of objects. So just so you kind of understand a little bit more, this is actually from your book. So the book that you have, a lot of the examples they use throughout all these chapters is the Circle class. They create a class called Circle. So I grabbed some of their slides and put them in here just as a reference. But, you know, we've created an array of like, what we did chars. You can do them as a class, like using a class. Like, say we created our own class called circle. We can create an array of circles, right? So here's the variable name. I'm creating an array of circles, and I'm saying there's 10 of them. And then from that point, you can call methods on that as well. So I'll show more examples of that as we go into classes. But what I wanted to really point out is that, you know, this circle array, that's the entire array, whereas in these is just a circle object. Okay? And unlike, really C++, when you create an array, this is, when you point to the array, it's this first element here, right? Whereas in really here, we are pointing to the whole thing here when we point to the array. And then you have to get the different elements. Okay? So methods. Okay. Recall what you learned in C++. Okay? Everything in Java is an object. We keep on repeating that. So you got to make sure that everything goes inside a class. So there's no methods outside a class. Okay? Unlike C++, because you could be more loose about that. And we don't have what you call functions. Functions do not exist. Really. They do not exist. Okay? Everything is within a class. Now, when you think about classes, you can create methods. Okay, well, let me go back. There's a couple other slides I want to first talk about before I get to that, because I really want, there we go. I really want this. So remember what classes have in any object-oriented programming, right? Any object-oriented programming, what do classes have? What do they have? I mean, you can read it, but think about it. What do they have? They basically have, right, data members, right, which are your variables, right? And they have methods. Object-oriented programming, right? Those are the two things that classes have. And they're contained in that class. They have attributes and they have methods. I love alliterations, so I always say attributes and actions, because I like alliteration. I made this slide, obviously. So they have attributes, and that's your variables holding information, your data members, as other programming languages call them, your data members. They could be varying types, right? They can be ints, they could be strings, they could be some new class we create, like say we create a class called student that holds student data. It could hold a student, you know, variable of type student. And then they have actions or behaviors, which are really methods, right? So that's what we're talking about here, right? Is in Java, because we're object-oriented and everything is in a class, we have attributes and we have methods. So let's go, we're going to go back now. I should have remembered what slide we were on. Was I here? Almost here. Yes, okay. So there's two types of methods in Java. We have instance methods and we have static methods. So the instance methods, those are the ones where when you create an instance of an object, right, you basically have your own, information, right? You have your own data members and that kind of stuff, right? Now static methods are ones that, you can also call them class methods. Do you remember that term, class methods? They are declared in a class, but they're not you get to call them without creating an instance of an object, right? So they're the ones, things like math.max. There's a whole bunch of classes out there where we have these static methods. You don't have to create an instance of math to call the max method. You can just call the max method on the name of the class. So those are the ones that are static methods, okay? They're more like regular C++ functions. So they're kind of taking the place of functions. But you always have to make sure you have your class name here, right? Because everything in Java is in a class. So everything has to be there. Okay? So they operate similarly, but you have to, the the instance method, you have to create an instance of the object to access it, to call that method, whereas a static method, you call it on the class. Okay? Like methods, right? Like you're probably used to, you have your method name, same rules apply. We tend to, like I said, start them lowercase, not uppercase. You have your return type and you have your arguments. So what you're really used to. The big difference is there's no separate function prototype and implementation. There's no H file and CPP, right? There's no telling us what methods you have and then programming them, okay? We only have the one file, okay? Classes are all contained in one file, right? And it depends on the programming language. In C++, you know, you have your H and your CPP, right? In Objective-C, for example, which is for iOS programming, you have an H and an M, right? So your class is made up of both files. Here, your class, one file. Okay? The Java docs can help create that API for you, is really what that kind of replaces. So simple method example is main. So main is what we call a static method, right? Because there's only one of them, and basically when you hit run, it knows, oh, I'm going to run greeting.main. It knows that. Because really it's greeting.main. It's not just main because it's in a class. It's greeting.main. So say we want to do some stuff and we want to call a method. Well, because main is a static method, if you want to call a method that's kind of like just like a function almost in your class, it also needs to be a static. So public static, this is the return type, this is the name. So double is the return type, calc average is your name of your class. And then here's your parameters. Does that make sense? Hopefully that makes sense. So we're going to be using this actually in lab 1 where you're going to, from main, you're going to be creating some methods here. Now, you could, I don't know if this confuses you. Maybe I'll bypass that and we'll talk about that later. Okay? Since both of these are static, no object needs to be created to use them. Okay. The bank program. Here's main. Math is a predefined Java class. We're calling the static method max on it. Okay. How are arguments passed in Java? So, you know, we're passing information through, you know, through the method. So there's this thing about passing by value. Now, do you remember sometimes you could pass by value? Whether you're passing the pointer, right? You're pointing to it, or whether you're passing the value of it, right? So with primitives, it basically is passing the value of it, just the value, right? It's just passing the value of it. Okay. Now, other variables are really object references that point to objects. So you can really think of it as the primitives pass by value. So like a copy of that information is just like, oh, in this variable holds the value 5. Okay, I'm passing 5 to you. Okay? But objects are really passed by reference. So anything that's an object, it's basically passing you the reference to it. It's like the memory location. So if you update it, it's getting updated, right? Because you're getting a reference to it in memory. Okay. Overloading methods. We can overload methods, which you've probably done that as well. The method signature is the method name and the number and types and order. I should write that. And order of the parameters. Okay. You can overload a method. So you have the same method, but the same name of the method, but different versions of it, right? This is what overloading is, right? So you have a method that says, I don't know, we haven't done any really good examples of it. Print something and you pass in different variables. So say it was print and different variables. You can overload that, so you can have another print method, but you have to alter the number and type. Okay? And it cannot be the return type. Okay? Notice how I've never said here the return type. Because we can't have two methods that say, like, get area. one returns a float and one returns an int, because it wouldn't know what to do with it. So that's not valid, but if you change the arguments, then it is. Okay? And in methods here, order matters, right? So the order and the type matter. Okay? Overloading operators not supported in Java. There you go. Okay, so classes and objects, just overview. File name must match its class name. So foo, the class foo is in foo.java. Foo.java is eventually compiled into foo.class, which is a bytecode. Okay? So let's take a really simple class, pair, and it has 2 data elements, right? Because classes have attributes and actions. So we have two attributes here, x and y. In C++, origin, like creating a variable of type pair, right? In Java, we would say origin equals new pair. Okay, it can be on one line. It's just because of the columns that got switched. But, and that's basically setting up the memory for it. Okay? And then here, you say origin.0 equals 0. Perfect. Here, right, remember, you won't see the stars here in Java. No stars. Here you're creating, if you created these P, Q, and R like this, then you would say P equals new pair. So we're always saying P. We're always putting the new. Okay? There's none of this stuff. Okay? And you would say then, because if it's a pointer, right, you would use the pointer symbol. We don't do that. Nope, 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 nope. So you'll just never see it. It's simpler, right? It's always the same. It's simpler. Okay. Like I said before, classes of attributes and actions. Classes define objects of the same type. Let's see, let's see, variables, methods, yeah. Okay, so you've heard of constructors before, constructor methods, C++, right? I'm going to tell you what's the special thing about constructor methods in Java. So constructor methods in Java, they are what we call just a special type of method, but there's 2 major things in constructor methods, and this is what you really need to know. That's from the thing. So what you really need to know in constructor methods is that constructors have the same name as the class itself. So you think of a constructor as a constructor method, right? So the name of the method is the name of the class itself, and there's no return type. No return type, and the name of the class, the name of the method is the name of the class. Okay? You can pass arguments, all that kind of stuff. Constructors, those are what are being evoked when we use that new operator. Every time you see that new, what it's doing is it's calling a constructor. And the constructor is maybe setting up values for you, initializing values for you. It really is, that's what's kind of setting that up and setting all that up for you. I think the best thing to do now is just quickly show you, let's do an example on Excel. So let's create a new class. And what would you like your class to be? We're going to create, object-oriented programming. We're going to create a class that has attributes and methods. What do you want to have a class? I mean, we could do boring like student or anything. Superheroes. I've done all kinds of things. Skynet. So that's an object. Is there attributes and methods for that? So that sounds like more like a machine object or computer that right? Or what am I okay, so let's create a new class. I'm going to keep it in this hello, we'll just keep it in hello world, that's fine. We are not going to put the main here. So our new class, Skynet, do you create instances of Oh, is this from the movie? Okay. Way past me. Okay. Any other simpler examples? How about like I did donut yesterday? I created a donut class. Anyone? Pet? Animal? Penguin? We can create a penguin class. Okay, so we're going to create a penguin class. I love it. Because there's different types of penguins. So I'm going to create a class penguin. Let's create, I just up front, good programming, let's put attributes. So we probably want a type, because there's different types of penguins. Like there's the Magellantic penguin, there's the king penguin. Penguins I know a little bit more about, right? There's all kinds of penguins. They have all their different fun little feathers. Type, say I have a friend who works at SeaWorld. She used to be in charge of the penguin encounters, so that's why I know a little bit more about penguins. They have names for all their penguins. All their penguins have fun names. So let's do some very simple attributes. Now I'm going to create a constructor for it. So like I said, the constructor is a method, but there's no return type. I'm still going to do my public. But there's no return type. And the name of the method is the name of the class. So no return type, public. It won't be static or anything like that. It'll just be penguin. So for example, what we like to do in here is this is where we would set default values. So maybe I set name, type. Maybe I'll create, just so I can have like an int, maybe I'll put the num children. How many children have they had? Something like that. I don't know, just to break it up with something else. Okay, so that would be a constructor. Okay, we can create multiple constructors. So you can have another constructor that, say it passes in information. Say it passes in the name. Okay, so I'm going to put name here, and I'm going to pass in my name. Okay, and then I'm going to set, yes?
Do you put public in front of each of them, or can you have like public and then have name?
No. So that's, I have slides like later on, but yeah, you have to put public in front of each of them. So in front of each method,
Okay.
right? You're used to doing like the public and then you put the colon and then
Yeah.
everything and then private.
Yeah.
Yeah, can't do that.
Can't do that. No.
Can't do that. No. Yes.
In that function, won't you be saying name equals name? Does that work?
Okay, that's a great point. So I could change the name of this, but I thought it'd be fun to kind of do it this way. So if I say name equals name, it's this variable, right, takes precedence. It's just basically setting it to itself, right, really not working, right? So I actually want to say, hey, I want you to change the attribute, right? So because the slides are coming up on how to do that, I figured I just might as well. So perfect. You can use this reserved word this. And the reserved word this basically means this object, this class that I'm in, this one right here.
Not the little method, not the function you're in, but
Right, so I put this dot name.
so that applies to the larger.
It applies to the larger class. It's the class. So this means the class, okay? And I can also do this as well, if I do this, then I'm not putting the default. What about setting these defaults here? How do I set these defaults before I set the name, right? I want to make sure that my number of children gets set to 0. I can use this with just parentheses, and what that does is when I use it like this, it calls the constructor. The constructor with no args. So this is a reserved word in Java, and it's very, very handy. It's a way to access attributes really easily in your class, as well as constructor. Okay. And we have things like, so say I wanted to create another constructor that passed in the number of children, and then this time remember, I used just num here. So there wasn't confusion, and it knew to use the attribute. And Eclipse is really nice about that. Notice how Eclipse is changing the color for you. So if you see this, it says, oh, yeah, those are those class attributes. Okay? And what we like to do in Java by convention is up here, we put our attributes first, we put our constructor methods next, and then any other constructor methods. Okay? And methods can't go inside of other methods, right? There's no methods inside of other methods. No, when you define a method, it's a method. And then another method, and another method. Theoretically, you could put these attributes, you could define another one here, define another one here. But that gets really messy code, and that's not the Java convention. Convention is attributes up at the top, and then methods. Okay? Make sense? Okay. So while we're working with classes, we might as well do this as well, is let's do some set and get methods, right? I'm a big one at trying to keep my information private, so I have control over who sees my attributes or not. So I'm actually going to make these private, so only people within my class can change the values of them. You can't do the dot notation. And I'm going to create methods to access those attributes, set and get methods. Or you may know of them as mutator and accessor methods. Have you heard that term? Mutator and accessor methods, maybe? So set and get. I have to say that Eclipse is so nice. Type set, hit Control spacebar. Oh, let's create a set type method. Set, let's create a set name. Set, see how they're all going away when I've already done them? Get. See how fast this is? There we go. Now I have set and get methods for my class. Great, huh? So I have set and get. I have and these are my constructors, so I'll label them. Constructor methods. Those are my constructor. And these are my set methods. And these are my get methods. And then, of course, you could write other methods as well that you wanted to do. Okay, so now that we've created this class, let's actually create an instance of it. Okay, so I can create an instance of Penguin as well. So in here, maybe I'll come down here after all this stuff, and let's create an instance of Penguin. So to create an instance of Penguin, we say Penguin, we give it a variable name, penny equals, and then we say new Penguin. Now at this point, we can choose which constructor we're going to, oops, I spelled penguin wrong. We can choose which constructor we're going to call. Right? When you create an instance of an object, you're only going to call one constructor, but you get to choose which constructor you want to call. So I want to make sure, oh, let's put the this in here as well. So I can say I'm going to call it, and I'm going to say Penny the Penguin. So I'm creating a new Penny the Penguin. Okay? Does that make sense? So that's creating an instance of that class. And then I can call methods on it. So then I could say Penny, Maybe set type. What kind of penguin is Penny? Maybe she's a, king is the easiest to type. King penguin. Maybe she's a king penguin, so I can set the type. Okay? And then I could call the get methods as well, right? So say I wanted to system.out.println penguin type, just because that's the one we, I could say penny dot get type. Okay, so, right, I'm creating an instance of penguin, I'm calling a method set type, and then I'm getting the type. It's actually going to return the type, so I'm just going to capture it right in that system.out and have it print for me. So if we run this, oh, please enter your name. That's right, we got to go through all this again. Java, and then finally penguin type equals king. Okay? Does that make sense? Hopefully. Okay, so that's how we create instances of objects. Right? We're going to use their constructor. You're only ever going to call one constructor. The default constructor. When there is no constructors, a class can be defined without any constructors. In that case, the no-arg constructor, which is the no argument constructor, will be created for you by the compiler, but you will never see it in your code. Okay, so that's the default constructor if you don't define any constructors. Okay, so here's declaring an object. Like here's an example of circle, right? So circle, my circle equals new circle. That's creating the object. Notice this is just like scanner. I mean, we were doing scanner, right? Scanner input equals new scanner. System.in is just a parameter, an argument in one of the scanner constructors. Referencing the object's data, use the dot date. You can use the dot as long as it's not private, and then or you can use like dot methods as well. So you'll see these keywords: public, private. There is this where you don't put anything. Public, protected, there's nothing, and private. We're going to talk about more later, but outside of class, the dot operator can be accessed. So if it's, I like to use private for my attributes, so you have to use methods to access them. Though if you don't, if you make it public, other people can reference it with the dot. Within a class, you can access the methods and attributes directly with no dot, and within a class, you can also use that this word as well to refer to something in the current object. So basically, this means current object. Okay, indentation, like I said, doesn't matter, but it is important as the coder and people that are going to be looking at your code as well. Here's just the help file on how to fix it. Command A, Command I. Here's the content assist, some nice helpful things for you, and refactoring. Okay, so we're done with lectures. Let's get to the lab. Lab 1. Okay, so go on to Blackboard.